Hi friends, welcome back. In the previous session, we have seen LTI systems, how to identify the LTI systems from the impulse response. That means from h of t or h of n. So we have seen these kind of things already. So I'm just giving you recapitulation. So let's see, suppose if a system is static LTI system, then it must have h of t in the form of k delta t. It must be in the form of k delta t, and h of n must be in the form of k delta n. So this is what the static LTI system. And if it is a causal LTI system, then we can say h of t is equal to 0 for t less than 0, h of n is equal to 0 for n less than 0. These are the things what we have seen. Next, suppose if it is a stable LTI system, then the condition is integral minus infinity to infinity mod h of t dt is less than infinity. That means h of t must be absolutely integrable, and for discrete time case, summation n is equal to minus infinity to infinity mod h of n less than infinity. That means h of n must be absolutely summable. So these are the two conditions. Next, suppose if it is invertible system, then the condition has to be h of t, that is a system, convolution with a inverse system impulse response hi of t has to be delta t. This condition has to be satisfied. Then in the discrete time case, h of n convolution with a hi of n has to be delta n. So these conditions has to be satisfied. Suppose if it is static LTI system, causal LTI system, stable and invertible system. So these are the things what we have seen. Just I am giving you a recap here. Okay. Now let's take one question again based on these conditions. Let's see example. I'm just writing the question. It's a true false question. If the impulse response of a LTI system is periodic, then it is always non-causal and unstable. Is it true or false? True or false? This is the question. Okay. So try to understand. They said impulse response is a periodic. That means h of t or h of n is periodic. Then it is always non-causal and unstable. Of course, it is true only. Correct. Why true, sir? Why can't it be false? Let's see. First, it is a periodic signal. If it is a periodic signal, the first and foremost condition has to be satisfied. If it is a periodic signal, it is existing from t is equal to minus infinity to t is equal to plus infinity. What is that supposed to mean? It is existing for negative values of time also. So Whenever the system is, if the system impulse response is existing for negative values of time, then it is non-causal, because for causal LTI system, h of t has to be 0 for t less than 0. It is not satisfied. So definitely it is a non-causal. Next, if it is a periodic signal, if you take modulus of that signal, then that modulus under that area under the modulus of the h of t, then it is definitely going to be infinity. So I can say yes, it is going to be true. So it is non-causal and unstable. It is always. Remember that. Okay. So for periodic signal, periodic exist between t is equal to minus infinity to t is equal to plus infinity. So that means h of t is not equal to 0 for t less than 0. That implies non-causal. Non-causal. And if it is a periodic signal, if you take modulus and if you try to find out area under the curve, it is always greater than, sorry, it is always equal to infinity. Then that means it is unstable. Unstable. So because of these two reasons, I can say it is always non-causal, it is always unstable. Okay, take it. You already got this. Okay. Question number 38. For Bibo stability, of an LTI system, which is true, which is true. Option A, h of t, that is impulse response, is integrable but may not be absolutely integrable. Option B, h of t will have finite support. Finite support. Option C, step response will be absolutely integrable. Option D, step response is bounded. Step response is bounded. So, which of the following option is correct? Listen here. First option, h of t is integrable but may not be absolutely integrable. That means he said integral minus infinity to infinity h of t dt is less than infinity. And here they said, but integral minus infinity to infinity mod h of t dt may not be less than 0. Less than 0. But we require this one. Mod h of t integration has to be less than infinity. This less than infinity or less than infinity or not, it won't make any difference for us. I hope you understood. So this is the condition what we require. That's why. So it may not be though. So in that sense, it is not the correct answer. It has to be absolutely integrable. If it is integrable or not, we don't care. We have to see only whether it is absolutely integrable or not. Next, second option. H of t will have finite support. What do you mean by that finite support? Finite support means it is bounded. That implies h of t is bounded. That's what the meaning of it. So whether it is bounded or not, it is not the matter for us. What we actually require, h of t must be absolutely integrable. That is also not correct. So option B is also not correct. Step response will be absolutely integrable. That means what they said, integral minus infinity to infinity mod s of t dt less than infinity. So that's what we require. Less than infinity, sorry. Less than infinity. That's what they are saying that. But here we require h of t. That means impulse response has to be absolutely integrable, not the step response. So this is also not correct. But if you observe carefully, the option 4 is correct. Why, sir? Step response is bounded. What is a step response actually? Step response is integral minus infinity to t h of tau d tau. So if it is bounded means this integral is also less than infinity. So definitely yes, option D is correct. Okay, take it. Let's see next example. Find the overall impulse response of the system. Find overall impulse response. Find overall impulse response. For this system, we require to find overall impulse response. Okay. Try to understand. This is a one system and this is another system. Two systems are cascaded. So if two systems are cascaded, then what is the overall impulse response? If I know the impulse response of this system is, let's say, h1 of n, and here we know h2 of n, then what is the overall impulse response if they are cascaded? That is nothing but h1 of n convolution with h2 of n. That is what the overall impulse response. Now, I don't know what is the impulse response of this system. I know the impulse response here. So I am trying to find out impulse response of this system. How we can do that? So listen carefully. We know one thing. For this system, if input is x of n, for this system, if input is x of n, we are going to get output is y of n. Okay, that's very good. Now my question, if x of n, the input is delta n, that means if I replace x with delta, then we have to replace y with h, that means h of n. I hope you understood. So whenever the input is impulse function, the output is called as impulse response h of n. So let's call it is h1 of n better, h1 of n, h1 of n. So you tell me, what is h1 of n here? For this system, what is h1 of n? Which is wherever x is there, that has to be replaced with impulse, that is delta. So simply it is delta n minus 1 by 2 delta n minus 1. So we got h1 of n and we got h2 of n. Then what is the overall impulse response h of n? Which is h1 of n convolution with h2 of n. h1 of n convolution with h2 of n. So I am taking here h of n is equal to, what is h1 of n, which is delta n minus 1 by 2 delta n minus 1 is convoluting with 1 by 2 whole power n u of n, 1 by 2 whole power n u of n. Now let's see, because convolution is a distributive property, first I will do the convolution with impulse, next I will do convolution with delta n minus 1. So if any signal is convolution with impulse function, it is going to be the same function. So which is 1 by 2 whole power n u of n minus 1 by 2. Any function convolution with the delta n minus 1, we are going to get the same function with the same shift. That means 1 by 2 whole power n minus 1 u of n minus 1. Now if you observe carefully, 1 by 2 whole power n minus 1, if I multiply them, minus 1 plus 1 get cancelled. So if I take 1 by 2 whole power n common out, we are left with u of n minus u of n minus 1. And we know this is a difference equation of step function u of n minus u of n minus 1, which results in delta n. So it is nothing but 1 by 2 whole power n delta n. And from the product property, any function is multiplied with delta n has to be replaced with 0. So if I replace n with 0, then this is going to be 1. Then this is going to be 1. Finally, this is delta n. So this is what we got. Finally, the impulse response is equal to delta n. Okay, I hope you understood. Now from this, I want to give more information on this. This function, this system having impulse response h1 of n, this system having impulse response h2 of n. If I convolute them h1 of n, h2 of n, what we are getting is delta n. What do you mean by that? Can I simply say for this system, this is nothing but the inverse system, and for this system, this is nothing but the inverse system. So from this I can conclude that h of n is equal to h1 of n convolution with h2 of n is equal to delta n. I told you invertible system having impulse response and inverse system having impulse response. If you convolute them, you are going to get delta n. So I can simply say h1 of n and h2 of n are inverse systems with each other. With each other. Okay, take it.